Hey, welcome everybody. This is the Nebari tutorial, so how to deploy your own Nebari, and we'll get into some of the details shortly. My name is Eskild. I'm a software engineer at QuantSight. You might see a few of us around. We have Peyton here helping Andrew in the back, and Adam as well. So yeah, we'll jump into it right away. If anybody hasn't logged in yet, can you maybe raise your hand and people can come around and help? Okay, great. So if you don't mind navigating to, so if you have logged in and cloned the repo, like it said, you should be able to access the 00 overview notebook. And this is what that looks like. So show of hands who has logged in and is on this first notebook. Sorry, is everybody on this one notebook? No, you can just start the small server, whatever server you want. You can start. There's only two GPU instances available, so it might not be enough for everybody. So open the terminal, and there'll be a link to clone the repo. All right, so we'll give it a few more minutes, but if you haven't done so already, could you please navigate to nebari.demo.dev, sign in with Keycloak, register at the bottom, and once you've logged in, you can start a terminal session, and it will give you a link to a repo which we'll want you to clone down. It should be nebari.dev / nebari demo. Your email address doesn't have to be your real email address. You can use whatever email address. Just make sure you remember it. So if you need to log in for the future, you can do so. Give it another minute or two. But if you have questions during the talk or the tutorial, feel free to raise your hand and we'll try to answer them for you. If they're too complex or they take too long, we'll maybe save them for the end. But if you have any technical issues, you should see a pink post-it note on your desk. We'll want you to kind of put it like this on top of your monitor so that we can come around and help those people who are having some technical problems. So. Okay. All right. Is there anybody who has not navigated to the 00 overview notebook yet? Okay. I'll walk through what it looks like for those who are wondering. So you'll sign in here. At the bottom, you'll hit register. I'm going to do. So this is what you'll do for the first time you register. Make sure you remember that. Make sure to remember your email address and password. And once you're signed in, you can start a server. You can pick a size, small or medium. It's fine. There's only two GPU instances available, so not enough for everybody. This should take you a couple seconds to load. We're mounting volumes and pulling images and whatnot, so it shouldn't take more than a couple seconds. If it does take a little longer, it's because we're having to scale up on the back end. And we'll get into more details, but it shouldn't take more than 30 seconds or so. And once you've been dropped into JupyterLab, you will want to open a terminal session. And on this terminal session, you'll see a link to a repo, which we'll want you to clone. So just copy that and then do git clone in your home directory. And you'll see it here. So can you maybe show of hands of people who have not gotten this far yet? Okay, very good. Okay, well, I'll log out of, I'll use my, this one. Okay, so I'm getting started right now. So there are some notebooks we put together for you to explore and for us to kind of go over what Nebari is and some of the core features. And at the end, we'll talk about how to actually deploy your own Nebari instance. So I'm going to start off by saying what Nebari is. So Nebari is an opinionated JupyterHub distribution that has that's running on Kubernetes, and it includes a whole bunch of features and services that we've integrated. It's been maybe a couple years in the making where we've taken all these core features and integrated them. We've also have a way of deploying it quickly via Terraform. So it should be a two-step process to initialize the configuration file, and then one more step to actually deploy your cluster. And that deployment process is it's all managed by Terraform, like I said, and it will be the thing that creates all those cloud resources that you need. Let's see here. I'm going to briefly, before we actually get started on the actual tutorial, I'm going to do something a bit different, which is I'm going to try deploying another Nebari instance from the current instance that I'm running on. So this is obviously not something you would do on your computer, but this shows you the process by which you would actually deploy a cluster. So just for the purposes of this tutorial, I'll start a deployment now, and then we'll come back to it at the end of the talk and see if it's up and running. So just to verify that this is not actually running right now, nebari.dev. You should. Okay. Someone must have deployed this. This is not my deployment. Well, that's kind of funny. I will change that name then. So this is the configuration file. We'll get into this in a second, but I just want to show you what it looks like to deploy. So have the command saved just so I don't mess it up. Yeah. So this is one command. It has some extra flags that we'll get into later on, but for now I'm just going to start the deployment process, and we'll see if it works. So we'll get back to this in a few minutes. There are some brief housekeeping. We already talked about how to log in. We'll have some opportunities for you to watch us demo some features that may not be accessible for all the attendees, but you can still follow along. And then there'll be some sections for each of you to experiment or play with the platform itself. So you'll see this kind of your turn section, and you'll know that you can play around it. We'll also, like I said, if you have any questions during the talk or tutorial, please raise your hand and we'll try to answer them. If they're more complex than we have time for, we might save them for the end. And if you run into technical issues, you can just use your pink post-it note and put it on the top, and Peyton or Andrew or someone will come around and assist you. So that's it. So maybe one final call out. Everyone is logged in and everyone's we're all on the same page. Okay, very good. If not, then please raise your hand or put the pink sticker on your laptop. Here we'll get into a bit more of what Nebari is. Like I said before, Nebari is an opinionated, open source, and scalable all-in-one data science platform that allows your team to work efficiently and collaboratively. We have some features that we like to show off that makes it easy for a team of data scientists to get their work done. We have a graphic here from our booth that shows some of the core features or core reasons why you might want to use Nebari. GitOps approach is opinionated, but it's still very flexible, so you can add other features and services that you might want, or change the ones that are currently deployed with. All the features that we have integrated are all open source. So Keycloak, Dask, Jupyter, and so on. They're all open source libraries. And yeah, we'll get into more of this in a bit. So some of the core features and integrations I'd like to highlight. Peyton will be going over Conda Store and Dask in a few minutes, and we'll also show off what it's like to share dashboards. But there are a whole bunch of other features that we just won't have the time to go over, but we've kind of highlighted them here for you. So feel free to explore on your own. we will be keeping this server or this deployment up and running over the weekend. So if you like to experiment, you can do so through the weekend, and then we're gonna remove everybody on Sunday evening. So, okay. Any questions before we get started? Okay, great. Next, I'm going to be moving over to the interfaces that we have set up. So there are a handful of interfaces that Nebari comes with out of the box, and the reason we have this is that many people like to work in different environments. So some people like working in notebooks, some people like working in like an editor or an IDE like VSCode, and some people like just to not have to deal with the browser at all, and they like to do everything from their local machine. So we have a way to SSH into the platform itself as well. So we'll get into those in a second. Okay, so now maybe the first part for people to get their hands dirty. If you go over to the left-hand side over here, you'll be able to see a file tree. I have some files in my home directory that you may not have, but that's totally fine. If you go to the shared folder quickly, you will see a handful of other folders within there. These are groups that you may be a part of. So I'm a part of these 4 groups, or I guess these 3 groups. The examples folder is a place for us to have some shared examples that we can play with later on. If you want to navigate to the analyst folder, you should see a rummy.py. I'm going to just show off that I can run this one quickly. So Python shared analyst run me. Very good. Maybe at this point you can try creating a folder, a file in this folder, the analyst folder, and maybe adding your name or some kind of unique identifier so you know that it's yours. But you should be able to see that everyone else in this room has access to that folder as well. So maybe just try creating a folder. You can do so by right-clicking here, adding new folder or new file, and saying this is mine. And this is a nice feature for people working in teams. You can have shared files that you that you use with your coworkers. You can have them all shared in one location. And this is also controlled by a permission system that we have integrated, the identity and access management platform known as Keycloak. And we'll get into that a bit later on as well. But suffice to say that there's rich permissioning built into the platform. So that is how you would create and make files in Jupyter. Next, we'll move over to the big plus button at the top, or from the file browser, you can go and click New Launcher, and then from there you can scroll over to, or you can find the VS Code pop out, and we'll click on VS Code. This is a feature that a lot of my coworkers like to use. They prefer perhaps working in VS Code as opposed to working in Jupyter Notebooks for certain projects, for example. And this is the code server VS Code in the browser application. So again, you can go to the file tree and you can see your files and what you're working on. But if you wanted to play around with this, you could go to the Nebari demo project, go down to the finance examples, and then there's a 01b VS Code demo.py, and this is a Py file that's riddled with some bugs, and you can use the built-in debugger with VS Code to actually debug this. But before we'll do that, maybe we can try adding an extension. So if you go over to the little set of squares on the left there, you can try adding an extension that you might want to use. I've added a few for myself, but let me see if I find another one. Down. I might just add Markdown Editor here and install, and then you'll have this in your environment for future, or when you go work in the future. So this is a nice feature as well. Okay, I'm going to navigate back to the notebook that we started with, which is the 01 notebook, and we're going to just briefly highlight as well that you can SSH from your local machine into the Nebari cluster. Here are some instructions on how to do that. It should be a very similar process to SSHing into any other machine you've done before. The only difference is that to do so on Nebari or in JupyterHub in general, you have to go and generate an API token. So you can go to the hub control panel here, at the bottom, and then it'll pop you out here, and then you can go click on token and then request a new API token. So this will be what you need if you're trying to SSH in. So at this point, I think we'll give folks maybe several minutes to just play around. There's some example notebooks at the bottom or some Py files. And if you'd like to try SSHing in from your local machine, there, like I said, the instructions are just right here. And we'll be available for questions and help if you have any need for it. So maybe we'll reconvene at let's say 11:22. So I'll give you guys 7 minutes to play around. But we'll be here for a while to help. Might try playing around with one of these myself. Economic. So we have one notebook that's pulling data from the Federal Reserve Economic Data dataset using a NASDAQ data link API. We have some exercises. The answers are hidden in these 3 dots, but try see if you can answer the question without looking at the answers, if you'd like. I'm gonna play around with this VSCode stuff for a while. At the bottom, you can always change your kernel, and we'll get into how we manage environments at a later time. But if you wanted to change your environment, you could do so here. I'm gonna run the debugger just to see what it's like. Python file.
Yeah, debugging in VSCode is pretty different than debugging with IPDB or something like that. So some people prefer this.
Yeah, I do. Okay, so see one error. Yeah.
Okay.
I was trying to think of ways to make this bugtastic. More than one in here. Okay. Oh.
Feel free to poke around the interface. I don't think there's very much harm that can be done.
Yeah.
Anyway.
Yeah, you won't be able to break anything. You pretty much do what you would normally do, and it should be fine. Oh, sorry. If you go to the 01 notebook interfaces, towards the bottom, there are some instructions. Let's see if I can pull it up here. They are SSH or SFTP from your local machine. The repo to check out. If you open your terminal, and there's a link on the side there, there should be at the very top a GitHub URL that says demo Nebari. I can type it in for you. This is what it should look like. Yeah. Yeah, there's a lot of yeah. When you're in JupyterHub or playing around in VSCode, there's not much you can do to actually break things. So play around as much as you like. And like I said, we'll have the platform up all weekend. So if you'd like to experiment or play around with some more, feel free to. Okay, we about have 1 minute left. How are people feeling about their progress on some of the exercises? Feeling okay? Okay. Good. I'm going to hand it over to Peyton now, and you can keep hacking around for a little longer, but Peyton will be introducing how to manage environments, how to scale your Python, and how to share dashboards.
Yeah, sure. Hi, everyone. I'm Peyton. I'm also a software engineer at OneSite. Yeah, so the first thing that I'll be talking to you about, can I close this out? Yeah. Okay, yeah. Terminal 1, right, Terminal 1. Oh, you're reverse scrolling. Of course. Okay. Right, so I'm going to talk to you about one of the core features, one of the things that I consider a core feature of Nebari. Right, so this core feature is called Conda Store. So most people are used to installing software on their laptops, but once you start working on data platforms, usually you have less flexibility installing the software that you want, because usually IT determines what software you can install. And often, if you want to install something new, there's like a request process for that. And that can take a long time. On top of that, a lot of JupyterHub distributions that maybe you've used before bake in the software environment into the Docker image. And so changing the environment means like a huge infrastructure effort. One, to like vet the package with IT, and then rebuild the Docker image and redeploy to the cloud. So Conda Store here is a tool that makes it easy to install software, and it gives you control over the software that you install while still being able to meet the constraints that are imposed by IT. So what do I mean by that? Well, let's just take a look at the existing Conda Store UI, and it will be more apparent what I'm talking about. And also the name will become clearer because Conda Store is actually a tool that's built on top of Conda if you're familiar with that. So so there's some instructions right here for managing software environments on Nebari. So so if you go to the file menu, whoops, what have I done? Go to the file menu, please, and scroll down. There's going to be a hub control panel down at the bottom. I think of this as like the home for Nebari, your Nebari home screen. There's a bunch of links on the top that we won't talk about just yet, but there is one for environment management. And this is how we're currently managing environments in Nebari. And if you click on this link, you'll see that there's nothing populated here for now. But in the top right, there's, if you're not using such a like zoomed in view, there's going to be a link to log in. And so if you click on that link to log in, you can use your username and password that you used before to access a listing of the environments. Here, I'm just going to use Auth0. And here, once you do that, you should see a listing of all the environments, software environments that you have access to. So let me explain a little bit more about what you're seeing right here. So on the right, maybe I better not step away, but on the right you can see the environment name. It's shown in like this teal background. So there's a geoenv, a demo xarray, environment, and a Nebari demo environment. So these are, you can think of them like Conda environments, again, if you're familiar with that. Just to the left of that are what we call namespaces. So namespaces are groupings of environments that are associated with your user permissions. So as a user, you can create new environments and share groups of environments with other users. And administrators can grant access or restrict access to certain groups of environments or namespaces. So that's what you're seeing here. And there's a little bit more information how big the environment is shown just nearby. I'll talk about these other links as well, but for now, you can create a new environment with this plus button up here. So click on that, and what you'll see is this this user interface that we have right here. It's a code editor. So the environments that are actually getting fed into Conda Store are YAML specifications. And so right here, I won't ask you to do this, but there's basically a YAML specification that looks a lot like a Conda YAML environment file. And so you would enter the name of your environment and dependencies here. Now, we're working on a UI, which is not ready for a demo, but I'll show some images of later, show a video of it, which removes the necessity of using a YAML config editor. And of course, you can also choose the namespace that your environment lives in. So going back to the list of environments, if you click on an existing environment, oh, actually, one thing I should mention. So the global namespace is accessible to everybody. So I think everybody should be able to see those three namespaces, or sorry, those three environments in the global namespace. There's probably also an environment with your username next to it, and only you have access to that environment. But of course, you can manage who has access to what environments as well using Conda Store. So let's take a look at the Nebari demo environment. And in here, you'll see an example of what that YAML spec actually looks like. It's a listing of some Python packages and some other software dependencies in here. And if I scroll down a little bit more, there's a button to edit the environment. And if I click on that, I can add new packages to this environment and submit the new specification to the Conda Store server, which will build the environment. And one of the really, really cool things about Conda Store is that when I make a change to an environment, it will always save an old version of an environment. It's like version control, but for environments. And so if I add a dependency that's not quite right, or somehow that it can't be added to the environment because maybe I mistyped it, or the environment can't be solved, you can always go back to an old version. And it's really simple to do. All of these are still environments that are accessible to me. So right now we're using build 21. I guess we've created 21 different builds on this Nebari instance. But I can always go back just by clicking this check mark next to build 18. And so now if I try to execute a notebook with this Nebari demo environment, it will be using build 18 of this environment instead of the most recent one. So I'm going to go back to build 21. I think this is like one of the most powerful, I guess, features of Conda Store because it introduces a lot of reproducibility to creating and managing environments. If I click on a particular build, you can see a bunch of log information about when it was built, whether it's successfully completed, and so on and so on. And also a listing of what packages are installed. And here we actually have it explicitly called out its Conda packages that were installed here. Oh, you don't have that one. I'm not sure. Yeah. So feel free if you'd like to. If you don't enter the right YAML, it will fail, but that's okay. I think it should just tell you. Yeah. Feel free to copy some YAML for a different environment. Okay, so this is our old user interface. It's very functional, and it gives a good idea of what's happening under the hood. Oh, one other thing. These links I mentioned before. One of Conda Store's explicit goals is to serve Conda environments in as many different ways as possible. And so you can take these links and share like a YAML spec, a Docker image, an archive, or a lock file with whoever you want. So I think this is a good way of giving other users access as well. We are planning on adding more ways of serving environments as well in the future. Okay, like I was saying, so this is kind of an older interface. We are building a new extension to JupyterLab to allow users to edit environments with a GUI. So that's in this new user interface. And you can see a video of this. Can I make this smaller? Is it Command minus? Okay, all right, cool. So let me just show off what this looks like right now. Here, I can pop this out. Okay, so this is what we're looking towards. It goes a little fast, so I'm gonna actually make it go slower right now. So like I said, this is going to be a JupyterLab extension. It is a JupyterLab extension, still in development, not quite ready for demoing. On the left-hand side here, there are a listing of the different namespaces that the user has access to. So this user has like a default namespace, a file system namespace, a finance, and a product namespaces. And you can see some of those are shared with other people. And if you click on one of those namespaces, it shows a list of the environments that are part of that. So this person has a couple of environments in each of their namespaces. And if you click on this little plus button, there's a way to create a new environment. And you can add an environment name and a description. And then further down, a way to search packages and add new packages of particular versions. So this person is adding NumPy of some version or other. And then finally, there's a way to enter which repository that you'd like to retrieve the packages from. And of course, the YAML editor is always there. That's really what's happening under the hood. There's some YAML spec that's being created from this GUI. And here they are just adding pandas. And when they click create, it submits this YAML config to the Conda Store server, and the environment is created. And at that moment, once it's finished, it'll show the status as completed, and that environment will be served as something that you can select in the JupyterLab notebook. So I think this is a really cool thing, because they didn't need to rebuild the Docker image, add in dependencies. It basically cuts a lot of the work of creating new environments out from current workflows. Right, and the user can also edit existing environments, add new packages, and so on and so on. Yep, so they're going to add xarray, and then they'll wind up submitting this new modified environment to Conda Store. And just as before, the previous build of the environment will be saved in this little dropdown. It's just a previous build that you can always revert back to if you really want. So again, this is something that's coming very soon. Wasn't quite ready for demoing at this conference. Yeah, and then finally, you still have links to log files, archives, and YAML files, and Docker images as well. And I think also we're going to add Podman support as well. Okay, cool. So that's the new UI that's coming down the line. Yeah. So going back to the notebook, I'm gonna make this a little bit bigger again. Maybe do Command plus, Command Shift plus. I don't know. Anyway, right. So I talked about these environments. These environments up in the top right. So usually that's how you select different kernels. When you create a new environment with Conda Store, the environment will appear here. The one we're using for all of this demo, by the way, the one that has all the packages that you need to run the notebooks, is the global Nebari demo. And it says global-global Nebari demo because the first global is actually the namespace that's added to the environment name. Okay, cool. Yeah, so if you'd like, you can swap over to the Xarray environment, and you'll be able to execute this cell down here, which requires Xarray but doesn't exist in the global Nebari demo environment. Okay, cool. So that's Conda Store. Next, we're going to be talking about Dask. So probably a lot of people are familiar with Dask. There were talks about it. I think a lot of people mentioned this, but Dask is a library which allows you to parallelize computing tasks really easily. And it lets you scale up from your laptop up to a huge cluster on the cloud. So if you're using a cloud computing service to run computations with Dask, you'll need to use something called Dask Gateway, which is a server that does cluster management for you when you submit a job to it. So the reason I'm talking about Dask has a lot of really cool notebook integrations that we've included in Nebari. There's actually a little Dask icon, which some of you have probably played with before. But let's just jump into an example. We're going to load a data set and run some computations on it. And in the process, you'll get to see some cool dashboarding that the Dask developers have built. Here's a GIF showing what it can look like with some of the dashboarding tools when you're executing. It's really cool for showing progress of tasks that you've submitted. So if you scroll down to the bottom, there's a little more information about Dask Gateway and so on and so on. But there's also a link down at the bottom for an adaptive scaling notebook. So click on that now. Okay, so in this first section, we're going to take a look at some Indian stock market data. So feel free to execute down to this first line break right here, where it starts this next scale to large data set with Dask Gateway section. Right, so this Indian stock market data, we can execute this. This first, what's going on? Ooh, did I do that? We're on build 24. Someone must have built a new Conda environment. All right, so I'm gonna switch the global environment back to 21. Okay, cool. Note for later on. That's all right. That's all right. That's all good. Oh, cool. That's all good. That's all good. Hey, Conda Store lets us give back to it, so nothing's broken. And I probably need to restart the kernel. Yeah, okay. I'm gonna restart the kernel. Okay, so the first cell is basically just getting the location on GCS where the stock market data is stored. And if we actually take a look at it, it's like 70 gigabytes, which you'll notice is way too big for our instance to load. So one of the cool things about Dask is that it provides drop-in replacements for a bunch of tools that you're already used to, like NumPy and pandas in this case, which is what we're going to take advantage of. And the syntax is like almost the same as running pandas. we can just execute some of it. So we're going to load Dask.dataframe instead of a pandas data frame. And one other difference that you'll notice with Dask is that data is lazily loaded. So it's some huge data set. We don't want to load it into memory, but we can still examine just a few rows of that data if we want to. And you can see it has no problem loading just 4 rows, 5 rows out of this thing. So. Okay, cool. But the next cell, if we were to uncomment this and actually run it, it would try to compute the max of some column of this massive data set. And we can't do that. Like I said, we only have 8 gigs of memory. So if you do that, it's not bad or anything, but it will just crash the kernel. So I won't demonstrate that here. So let's actually scale this up to a large Dask cluster so that we can handle something like this. So feel free to work through the next section. I'm going to get some stuff running because it takes just a minute to start all the workers. What I can say is there's a couple of warnings in this section on the options about the size of the workers, and the small workers are faster to launch than the medium workers. What's that? Okay. Yeah. And what I should mention is there's a Dask kernel up here as well, which has the right package for this. Okay, so I'm going to import the Dask gateway and then set the cluster options. One of the really cool things about Dask is it has tight notebook integration. So when you run this options cell, there's going to be an option to set the environment. As long as your environment always matches the environment of the notebook you're trying to execute, then your workers will be happy and your tasks will compute successfully. And like I said, the small workers execute or start up faster than the larger ones, so I'm just going to choose some small ones right now, and I'm going to execute a few other notebook cells as well because it just takes a few seconds. So going back to the top here, this first cell is establishing a connection to the Dask gateway. And you can see that there's actually a link to the Dask gateway right here. And once you do that, then you can start setting options on the Dask gateway related to configuring your worker. And that's what this next section is. Again, these nice IPy widgets that the Dask developers set up allow you to configure this stuff. One other thing, the cluster profiles that I mentioned, these are all something that you can configure using the nebari config.yaml, which is like the single config file that you need to deploy a Nebari instance. That's something that Esko will talk about later on. So this has some compute profile. I'm not sure what it is, but again, it's something that you can configure. And same with the environments available here. Right. So the next thing to do is to actually create a new cluster with the options that you selected. And once you do that, there's some information pops up about how you want the cluster to scale. So you can enforce manual scaling, say, I want my cluster to have 10 workers or something like that. Here, we're going to use adaptive scaling. And you can either use this widget to configure that, or you can do that programmatically down below, which is what we've entered into this notebook. So we've told this cluster we want to run between 1 and 10 workers, and the Dask scheduler will scale up as necessary up to that maximum. And then finally, once you have a cluster started, you can get the client, which if you're familiar with Dask, you will have seen before. Now, before we go further on, when you display this client in the notebook, there's a handy link to a dashboard. So if you would click on that link, there should be a login screen that you come to you might come to a login screen which will ask for credentials. And if you enter your credentials, it'll take you to this really cool dashboard, which shows a lot of information about how the cluster is doing, what it's doing, what tasks and system resources it's consuming, and so on and so on. So that's really useful, but you can also take advantage of the notebook integration that Dask offers by clicking on this little button on the left-hand panel. It's a little cut off, but I think you can see where I'm clicking. And initially, it'll say the dashboard's not connected. But if you just copy-paste this dashboard link into here, and then click the little magnifying glass, if your cluster is up and running, you'll get a selection of different widgets that you can use during your computation. So I like to use the cluster map, so I just click on that, and it opens up this handy little extra tab. And I'll also get the task stream, because that thing's also cool. So I'm going to put that there. Cool. And then in the interest of not crowding everything, I'll close that off. Okay, so then now we have our dashboard set up. We've established a connection to Dask Gateway and started a cluster. We're now ready to run some processing on this data. And if you want, you can uncomment the next cell and actually run this. It takes a minute or two to run because it's 70 gigabytes of data, and so yeah, that takes a little while. So feel free to do that if you'd like. I'm going to show you just a shorter demo in the interest of time using Dask Array, which is the drop-in replacement for NumPy's ND arrays. And if you've seen this before, or if you've used NumPy before, it all looks pretty familiar. Like all of this is NumPy compatible syntax up until you get to the point where it says compute. And you can think of the previous notebook cells as like setting up the computation and then the compute as saying, okay, go ahead and do this. Because again, Dask is lazy execution by default. And when I run compute, I will submit the task to the cluster, and you can see that it's doing something right now. So it's got one node in this cluster map. So this represents like the main node, and this is a worker. And so it's transmitting some data to the worker, and there's some task stream. And if you have adaptive scaling enabled, Dask will recognize that you have a really big task for it to compute, and it will automatically add other workers as necessary to scale up appropriately. So now we have 4 going, there's lots of data being transmitted everywhere. It's great. Yeah, and so this will run for just a moment, and eventually it'll decide that we haven't gone fast enough, and it'll add a ton of workers, and then right as we do that, it'll end. So that's pretty cool. I love these visualizations. They're really interesting and useful. And at the end, we've computed the mean of some random array. So yeah. Okay, so the last thing to do before we end with this notebook is always close down your cluster, because these are things that are running in the notebook, and they're actually running on some computer somewhere. And so yeah, they cost real money. Cool. Okay, so the next thing I'd like to get to is dashboards. So, so many of you have probably heard of some of the really cool dashboarding tools that exist in the Python ecosystem that allow you to build like interactive data visualizations and turn them into web apps, essentially. So some of these are like Voila, Bokeh, Plotly Dash, Streamlit. There's a bunch of others as well. And we in Nebari, you have the capability of creating and hosting dashboards like these. And it's all built on top of Keycloak, which is our permissioning system. And so it makes it really easy to share dashboards with other users, with whoever you want. So let's walk through making a dashboard. So if you scroll down here, there's a section that says, how does it work? And it's pretty straightforward if you're familiar with one of these frameworks. The idea is that you create a Python file or a notebook built using one of these frameworks, and there's a nice interface in Nebari to actually do that. So, so we can demo this live. So inside the home directory, there's a shared folder, and inside there's an examples directory as well. And inside the examples directory, there's a couple of notebooks and Python files which are built using these frameworks. They're just really simple visualizations. Not going to ask you to write these, although you can if you would like. What I would suggest doing is going to this directory and right-clicking. How do I do that? Oh, it's two figures. No, there it goes. All right, and then copy the path, because this is what you'll need later on to actually launch one of these dashboards. And then we go back to the hub control panel, which is our Nebari home. So click on that. And up at the top, you'll see next to the environment management tab, you'll see this dashboards link. So click on that there. And here, you should see this new dashboard button. There's also going to be down below this dashboards from others. I'm on Eskil's account, so it's showing a different dashboard that I've already deployed. I think you should be able to see that extra dashboard as well, but I'll show that to you in a minute. So click on the new dashboard link and give it a name. Task dashboard 1. Yay. And you can give it a description. And like I said, there's the possibility of restricting access to certain users or granting access to all users. So that's something that you can configure here just by clicking on these buttons. For now, I'm going to let everyone see this dashboard. And finally, you can choose whether to source a dashboard from a Git repository, or in this case, we're serving a file from the Jupyter tree. So I'll just keep that here. And then down at the bottom, it asks you for the path to the dashboard that you want to host. So just paste in what you've copied, and then select the framework that you've chosen. So I chose this dashboard Streamlit example, so I'm going to choose the Streamlit framework. And finally, there's some Conda environments here. I'm going to use the global Nebari demo environment. Then if you click Save, it'll ask you what kind of instance do you want to serve this on. I'd suggest a small instance, but it's up to you. You probably don't need the compute resources of everything. And it will start, and it takes another minute. I know some of you took like a few seconds to get your JupyterLab instance up and running. It's the same story here. It's starting up some pod and doing that. While that's loading, I can show you. Oh, look at that! Everybody's already done all these. So I can show you the New York City taxicab data, which surely you haven't seen before. Yeah, so this is what it looks like when you build one of these dashboards. I think this is super cool. You can share this kind of information with your coworkers, and I just think it's a great way of displaying data. There's a little slidery thingy right here that lets you choose different pickup times, and it updates all the plots in real time. Cool. So I think that's it for dashboarding. Yeah, feel free to check out the other dashboards that people are creating. There's definitely more information about this. We're using something called CDS dashboards to actually accomplish all of this. There's some other examples in there, so feel free to check those out. For now, I think we should probably move on to the setup section. Okay, let's go.
how's everyone doing so far? Good. Okay. Well, so far we've demoed a handful of features and services that are integrated by default into Nebari. But you might be wondering, how do we actually deploy a Nebari instance? And this is what we're going to talk about now. If you were here at the beginning, I did kickstart a deployment off using a single command, and we're going to revisit that and see if it's actually deployed successfully. It should have taken about 30 minutes to 45 minutes, so hopefully it's done by now. We wanted to just highlight some of the key takeaways from this particular notebook, which are that you can initialize your Nebari configuration, so the Nebari config.yaml with a single CLI command, and that single config file controls all the controls everything about your Nebari cluster. So you don't need to make any changes anywhere else. This is the one place where you would make those changes and then redeploy. And then the second thing being that the deploy command itself is very simple. Under the hood is all managed by Terraform, so we're passing the inputs from the config file over to a Terraform script, and the Terraform is the one actually deploying and making those changes. So there's a lot of information here about what it's like to get started, but I just wanted to highlight that one of the reasons why we think Nebari is a useful platform is that we spent a lot of time integrating all these services and making it as easy as possible to deploy. So, all these things are possible. You can integrate all these services into your own JupyterHub, into your own Zero to JupyterHub. But we've done all that work for you, and now you can kind of just get started right away and not have to worry about the administration and IT components of managing a JupyterHub. So, if we want to follow along or have a look at the CLI, we'll do so quickly. But I just want to highlight this one image, I guess, which kind of outlines what the CLI kind of tries to do. So there's a init command, and there's a deploy command, and there's a destroy command. The init is what like I said before, it generates the config file, and the deploy is what actually is used to deploy the cluster. When you're done with your deployment, you can always run Nebari destroy, and it'll do the job of destroying and removing all the cloud resources that were created in the second step. But for now, if we want to move over to a terminal, so we have a terminal open like I have here, you should be in the global Nebari demo environment. It should have been started for you automatically, but if not, then you can just run Conda activate global Nebari demo. Already there, so that should be fine. If you run Nebari, this is a relatively new CLI that we've just added. We're still kind of experimenting with it, but I think it looks quite neat, and there are a handful of commands and some help messages that might be helpful for people getting started. The big three that I like to call out, like I said earlier, are the init, deploy, and destroy. So let's have a look at the init. So if you look at the help command, you'll see that there are quite a few options that you can pass to your init command. These are actually we're trying to get some information from the user and then add those options to the configuration file. As you can see, adding all of these options to a CLI command can be quite cumbersome. So we've added a guided init. So that's what I recommend people getting started with. So if everyone could do Nebari init -- guided - init like this, it'll walk you through a quick questionnaire that'll help generate this config file for you. So we'll hit enter. There are some links and helpful information about what this config file does and where you can get more information. Demo.nebari.dev is our homepage. Have a look at it when you get a chance. And then there are some other messages here. So the first question it's going to ask is where do you want to deploy your Nebari cluster? So at the moment we have a few options. Local is how you would deploy it if you wanted to deploy it on a local machine, so your actual computer or laptop. Currently this is only available for Linux OS, but we're working on adding support for obviously Mac and Windows. Existing is how you would deploy a Nebari cluster on an existing cloud provider. So We have 4 options listed below, but if you are trying to deploy on a cluster from a different cloud provider, you could do so. I know I have personally deployed Nebari on Oracle Cloud, so that's another option. But for now, you can just select any of the 4 cloud providers you'd like. So I'm going to do let's say I'm going to do DigitalOcean. I'll type in you don't need to type in an actual token; it's fine. Just type in something so it registers some keystrokes. And once you get past that section, it'll ask you about what kind of project name you'd like to give your project. So in this instance, our project name is demo-nebari, but you obviously want to pick a name that's appropriate for you and your organization. So maybe do something like PyData NYC as my project name. Next, we're going to give a URL, or sorry, a domain name to the config. This is where we would actually be deploying our cluster to. So make sure you own that domain name, but you can type in something like PyData nyc.nebari.dev. The next question is going to ask you about the identity provider you'd like to choose. So at the moment, we have a few options: GitHub, Auth0, or custom. So custom is you can pretty much add any other identity provider if it's not listed here. Or you could just do the very most simple option, which is password. So everyone has a username and password, and that's how they log in. So we'll just do that for now. GitOps is a way of managing the deployment in the future. So the first time you deploy, you'll probably do so on your local machine, but thereafter you might want to pass this job off to a CI/CD pipeline, and this is how you would do so. I'll just give an example of what kind of questions you might be asked. So at the moment, you can deploy your Nebari cluster from GitHub or GitLab. Just GitHub for now. You would add a org, so I'll just add my my username on GitHub and give it a name. So PyData NYC. And then ultimately, if you have your GitHub token exported, it'll actually create this repo for you on the fly, but I won't do so right now. Another option that is recommended is adding an SSL cert, and if you add an email address for the next question, we will automatically generate a Let's Encrypt cert that'll be applied to the whole platform, so you don't have to worry about that, and it automatically renews in the background, so there's none of that SSL cert managing that needs to be done. So I'll select yes. Oh, shoot, I didn't have an email address. Anyways, the next questions are more of the advanced configuration items, and you can have a look at what those are, but for the most part, they're not all that important for basic deployments. But if you have a look, you can say, oh, where do you want this Terraform state to be provisioned? Locally, remote. Remote is the default. What namespace you want your Kubernetes cluster to be deployed under? Dev is the default. And if you have a version you'd like to use, and you can select a specific version of Kubernetes, but we won't do that either. So, anyways, once you hit enter, you'll see a whole bunch of text at the bottom, and you'll see that we have generated a Nebari config. So if you just cat that out, you'll see there are a big YAML spec that talks about what defines what your Nebari cluster will look like. So I'm actually going to open this in. So yeah, anyways, so we'll go to the top and just kind of walk through some of these sections. The project name we talked about before earlier, the provider, so DO stands for DigitalOcean, and then the domain name under which you'll be deploying, certificate we just talked about as well. Security and authentication, we selected password as the most basic option, but like I said, you could add GitHub authentication, Auth0, which is what we have as an organization here at Quantsite. Keycloak root password, this is how you would first log into your Keycloak admin console to add and remove users, manage groups and permissions and whatnot. We have here the list of default images for the JupyterHub and JupyterLab and Dask Worker. These often are not changed or touched, but if you need to, you could do so. And there's a whole bunch of other changes you can make. You can update the theme that you see when you first log in. The theme that you're seeing is the default theme, but you could always customize that to your organization or the team you're working on. You can enable and disable a whole bunch of features. We talked about the CDS dashboards. You can do that there as well. And towards the bottom, you'll see some more cloud-specific configuration items. So these are the node groups that are being deployed with the cluster. So we have 3 node groups: general, user, and worker. So worker is where the Dask workers spin up on. User is where the users log in, and that's how they get those. These are the default instance types for those users. And all this can be configured. You can change the max and min. You can combine these two together, add other GPU instances, and so on. So this is where those changes would be made. And then you can define from those instances what kind of profiles are available to the user. So small is splitting up the big instance or the user instance into 2 different profiles, and the medium is putting all the resources in on one node. And at the bottom, we've also just included 2 default environments that build automatically so that people can get started using Dask and dashboards without having to fiddle with managing environments right away. So that's the Nebari config. Any questions about the config file? I know there's a lot of different sections, but once you get used to looking at it and deploying it, it should be fairly straightforward. Okay, I think I might move over to having a look. Oh, sorry. Right. Yeah. So if you wanted to have it be if you want the repo to be created for you automatically, then you'll need to export those credentials. If you just want it to be if you just want to list what repo you're actually going to be deploying to, you don't actually need to have your token exported. So let me see if I can show you real quick. So if I go to this section right here, this is we're asking that question because we're going to be pushing this repo up to pushing this config file up to a repo, and then once we render a handful of workflow files, then this will kickstart any deployment in the future. So if you make a modification to the Nebari config, you open a pull request, and that pull request gets merged back into main or whatever other branch you want to specify, then that will kickstart the deployment for you. So that's a way of making it easy for people and teams to manage their deployment without having to do so on your actual local machine. Okay. Yeah, that's right. Yeah. 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 Maybe since I have my browser open, I can just maybe navigate to and show what it looks like real quick since we're on this topic. So the deployment that we're actually working on right now, this is what it looks like in GitHub, for example. So last night I opened a pull request to increase some resources on the platform. And once this got merged back into main, you'll see that it actually kicked off a redeployment. So where's the action? Yeah. So this is actually running the deployment. Took 13 minutes because I had to do a handful of bigger changes, but usually it's pretty quick. And this is the entire deployment script happening all within GitHub Actions, which is really convenient to not have to do it on your laptop. Let me go back to where I was. Okay, so We talked about the init. We talked about the deployment. So now let's see if the deployment I kicked off at the beginning of the talk is actually okay. Very good. It actually did work. So I'm going to navigate to the PyData me.nebari.dev and show you that this was just deployed while we were talking. So in the background, I had the config file which we generated, and we now deployed it. And it took, like I said, 30 minutes to an hour, depending on the internet connection and some other things. But now you have the entire cluster up and running, and now you can add users, make changes to your theme and whatnot, and go from there. So that's one of the main motivations, I think, for using a platform like Nebari is that it's really easy and simple to manage, and the deployment process is quite simple relative to some of the other platforms. So that is it for the setup and the deployment steps. But any other questions on that front? They're very similar, yeah. The current demo that you see is basically the exact, or is pretty much the vanilla Nebari deployment. There have been a few changes to allow for us to include so many users, and we've also made some changes to we added some environments, and we've added the ability for users to log in without having to register, or yeah, with only having to register. Usually that wouldn't be the case. You wouldn't allow people to register in a deployment like we have here, but we obviously need to wait for you guys to all jump in quickly. So there are very minor changes from what you see and what an actual vanilla Nebari deployment would look like. Good question. Mm-hmm. Yeah, that's a good question. Yeah, that's a good question. So I'll show you the command that I ran to deploy with. So normally it would just be this first top line, which is nebari demo.-c, and then the config file. If you have Cloudflare as your provider, you could add that there, and then you have this DNS auto provision that will automatically do it for you. If you don't, at the moment that we only provide this service for Cloudflare, but if you have your own service, partway through the script, it'll stop and it'll ask you to map your CNAME or your A record to an actual IP address on whatever domain provider you have. So that would be a manual process during the deployment, but if you're using Cloudflare, you can do it automatically. So, but that step is only a one-step, one interruption during the entire deployment. So, but that's a good question. And we're going to wrap up by going over to the last notebook, which is the conclusion notebook. I think we've covered a lot in a short amount of time, but I hope we have made it clear what Nebari is and what some of the features and core services are. Conda store for managing environments, CDS dashboards for sharing dashboards, Dask for scaling up your compute fairly quickly, and then lastly, we also talked about how easy it is to get started with generating an init file and then deploying it on the cloud provider of your choice. We have some brochure or some brochures that we've added into the notebook. You can kind of look at it some more, but this is the point where we kind of open it up for questions. There are some additional features that you can check out here as well. We've integrated Argo Workflows, Kbatch, monitoring dashboards, not quite CDS dashboards. This is a different way to just check in on how your cluster is doing, and then obviously there's the Jitsi video chat on the right here. Anyways, but thank you very much. I'd like to thank you all for coming, and also thank a whole bunch of people who worked on this: Chris and Tanya, Vinny, Avita, Amit, and Darhas. This is the main core development team at the moment. We have Adam obviously has contributed a lot. Ani, one of our other coworkers, has contributed a lot as well. And lastly, we've integrated a whole bunch of core data, PyData platforms and services into the platform. So this wouldn't be possible. It wouldn't be possible if we didn't have the support and packages such as Jupyter, Dask, CDS dashboards, and a whole bunch of others. So I'd like to give them a huge thanks as well. But that's about it for our tutorial. Now we're going to open it up to questions. But thank you very much.